welcome to our first day. And since we are obviously in a chemistry class, let's remember that chemistry is the study of stuff, by which we mean matter. And you may have heard that matter has often been defined as anything that takes up space and has mass. Our entire year in this course will be spent in studying matter, how we identify it, how it reacts, how it behaves in a reaction. I have always been fascinated by this stuff. And the first thing that we're going to do is ask ourselves, how do we describe matter? We do so using what we call properties. Let me give you an example. We're going to break properties up into two types. Obviously, there are a lot of different properties that we can use. We're going to describe matter using chemical and physical properties. Let's take a look at the physical properties first. So we're going to break physical properties down further into two different types. And we're going to describe two types of properties such as extensive properties. Extensive properties depend on how much you have, so they change all the time. I'll give you a couple of examples. A good example of an extensive property is mass. Literally, how much of it do you have? Here we have three different lead weights. We're going to describe their mass and get into units fairly soon, but these are all being measured in a unit called the kilogram. Clearly, 500 kilograms is not as much lead as 1 kilogram, not as much lead as 2 kilograms. Another good example of an extensive property is volume. All you have to do to change the amount of volume is add or remove some liquid, or depending on the shape of the container, you can change the shape of it. It's easily changeable. So extensive properties, they're not really useful to describe what a type of matter is, but they are pretty useful for describing how much of it you have. We'll contrast extensive properties with what we're going to call intensive properties. And these are specific to a substance. They don't depend on how much you have. They are constant. They stay the same no matter how much of a substance you have. Let's take some examples here. A good example of a physical property is appearance. This can be a lot of things. It's color, shape, texture, state of matter, whether it's a solid, a liquid, or a gas. Size can be a physical property, although we've already determined that can often be described as volume, so we'll keep that as an extensive property. Obviously, here's a tennis ball. You could describe that. Someone will describe something as being tennis ball yellow. Here's a good example. This is tennis ball yellow Civic. If you were to buy a Honda Civic and it was this color and someone asked you to describe it, you would say tennis ball yellow. They would know exactly what you're talking about. Another good example of an intensive property is flexibility. Words that we might use to describe flexibility would be malleable or ductile. And all this really means is that they can be stretched out or flattened. A good example of a material that has high malleability or ductility, something like copper. It's clearly a metal. We'll get into what metals are soon enough, but you've probably seen copper in all different kinds of shapes and sizes. It can be solid and heavy, like solid copper rods, or we can stretch it out into thin wires like this, or even leave it in a big solid chunk called an ingot that looks like this. That's an ingot. Now, could you do that with wood? You can't stretch wood. You can't mash wood flat. I mean, you can shape it, but it requires a much different technique. It lacks malleability. It lacks ductility. It's not flexible. If we had a substance that was like wood or glass, you can't really do this with glass unless you heat it up, way high. We would say they're not necessarily that they're malleable or ductile. We would say that they're rather brittle. They lack this flexibility. They lack this ductility. A good example, wood or glass. These would be good examples of materials that lack flexibility. Another good example of a physical property would be boiling point and melting point. They vary wildly. For example, here's a good example of how wildly varying boiling point and melting point can be. We're using the Celsius scale, not Fahrenheit. Check this out. If you want to boil water, you have to heat it to 100 degrees Celsius. That's easy. You can do that on a stove. But if you want to boil iron, that is, if you want to turn iron from a liquid to a gas, you have to heat it to 2,890 degrees Celsius. A huge difference. If you want to melt ice, all you have to do is heat it to 0 degrees Celsius. If you want to melt iron, turn it from a solid to a liquid, like they do in forges or when they're pouring cast iron, you have to heat it to 1,540 degrees Celsius. It's quite hot. Another good example of a physical property would be conductivity. This means, does it allow the passage of heat or electricity? Typically, items that are metals, for example, iron, I talked about copper, lead, these tend to be good conductors. They let a lot of electricity, they let electricity easily flow through them. This is why they are components in wiring. You wouldn't get very far if you tried to use non-metals as conductors. These would be good examples would be wood or rubber or glass. They tend to be bad conductors, and so we tend to refer to them as insulators, otherwise known as bad. If we're going to try to describe matter using what we're going to call chemical properties, it's real simple. What does it react with? I'll show you an example. We're going to take a copper penny and we're going to react it with something called sulfuric acid. We're going to see what happens. And then we're going to do the same thing by taking a copper penny and reacting it with something called nitric acid. And we'll see what happens. So let's take a look. So now we're going to look at what we're going to call chemical properties. These kinds of properties describe how a substance reacts. I'll show you a really neat example. So here we have two very strong, very concentrated acids. The one on the left with the yellow cap is sulfuric acid, and the one on the right with the red cap is nitric acid. These are really strong, and this reaction is really dangerous, so I'm doing this in our fume hood, and I'm going to turn on the fan in a little bit. Now what I'm about to do here is I'm going to throw an everyday penny, one of these guys, into our sulfuric acid, which is again on the left, and then I'm going to throw another one into the nitric acid, which is on the right. This is a great example of what we call a chemical property, meaning
how does something react? Let's keep in mind that your average penny is, for all intents and purposes at this moment, copper. We'll explore that more later, but for right now, I'm just going to assume that it's copper. Here's what it looks like in our sulfuric acid. Ready? Watch. Not very exciting. Although if you look very closely at our penny, you'll see that it is now bright and shiny because sulfuric acid really does a good job of getting rid of all the tarnish and gunk that piles up on coins over time. Other than that, nothing happens. So copper isn't really reacting, or in other words, sulfuric acid does not react with copper. Now we're going to take our penny. We've got another one very similar to the first. Again, we're going to assume for the moment that this is pure copper. And we're going to throw this into our concentrated nitric acid. And I'm going to turn on the fan. Swing and a miss. Because this reaction is rather violent. Notice that we are getting a very dense brown cloud. Obviously, in the video, you're not going to be able to tell that there is a rather noxious odor. This is a gas that's being produced. It is almost a pure oxide of nitrogen. And you'll also notice that at the bottom, where what was previously a clear liquid has now turned bright green. In fact, if we were to let this go for a while, you'll see that there's nothing left of our penny, and that our solution has turned bright green, which we'll look at as this runs. I think that reaction is done. Let's take a look and see what's left of our copper penny. Our penny in sulfuric acid looks exactly the same, bright and shiny. We can take it out, go spend it, buy a Bentley or something. But where our copper penny was in our nitric acid, completely gone. Nothing left but this blue-green clear liquid. Our penny is gone forever. It went up the chimney. We'll never get it back. It's a good example of a chemical property.
So let's recap. We know that chemistry is the study of stuff, otherwise known as matter, which is anything that takes up space and has mass. And we're going to describe it using what we call properties. Physical being just how we describe it. Things like mass or volume, depending on how much of it that we had. Or intensive properties, such as appearance, like its color or its texture, its state of matter, its flexibility. Can it be stretched or flattened? Can it be turned into an ingot? Or is it brittle, like wood or glass? Another good example of a physical property would be boiling or melting point. There are wildly different boiling points and melting points for different substances. And they are intensive properties, meaning they are constant. Doesn't matter how much you have. One molecule of water will boil at 100 degrees Celsius just as much as an entire pot will. Is it conductive? Does it allow the passage of heat or electricity? Metals are good conductors. Non-metals tend to be bad conductors. Another way to describe matter with what would be called chemical properties. For example, what does it react with? And we saw an example of copper reacting with sulfuric acid versus copper and nitric acid. Let's remember that when we reacted our copper and sulfuric acid, nothing happened. But when we reacted our copper and nitric acid, we got a massive reaction. So, hopefully you enjoyed it. I had fun doing it. So, I'll see you guys on the next one.
Oh, and here's an example of a physical property. A substance that's flexible versus a substance that isn't. Flexible substance? not flexible substance.